Hi. Today, you guys are going to be learning about solving quadratic equations by using factored form in Unit 7, Lesson 9. I know in previous lessons you may have actually learned how to solve quadratic equations by graphing, but today we're going to use what we've learned in the last couple of lessons to help us solve equations mathematically, or how can I say algebraically. So again, I apologize in advance if I make any mistakes. I will try to fix it along the way. Um, yeah. So, all right, let's begin. 9.1. Why would you do that? Let's try to find at least one solution to x squared minus 2x minus 35 equals 0. Okay, so we're going to choose a number between 0 and 10. I'm just going to pick a random number. Let's try 3. Okay, so how do we figure out what to do next? Evaluate the expression x squared minus 2x minus 35 using your number for x. So we're going to set this as equal to x. And what you guys want to do is substitute it in for the expression. So we're going to take the fact that we know this is x, and every time I see an x, I'm going to substitute it in. Okay, so 3 squared minus 2 times 3 minus 35. I'm just going to scoot this up a little bit more for you guys. There we go. Just want to make sure it's free focus. So substituting it in for x and then now solving. Well, 3 times 2, or sorry, 3 squared is 9 minus 6 minus 35. And that is 3. That's 9 minus 6 is 3 minus 35. And that is a negative 32. That is not 0, which is what we want, is a 0. So x is not a solution in this case for that equation. And that's the idea of this warm-up, is just getting you guys used to like understanding solutions. So right there, if your number doesn't give a value of 0, look for someone in your class who may have chosen a number that doesn't make the expression equal to 0. Which number is it? And in this case, it is 7. So let's see if 7 works. Okay, so we're going to substitute it in again and see if we actually get a number. So 7 squared minus 2 times 7 minus 35. See what we get. 49 minus 14 minus 35. That's 35 minus 35, which equals 0. And that is what we wanted, right? There is another number that would make the expression x squared minus 2x minus 35 equal to 0. Can we find it? Well, it happens to be -5. So let's just double check to see if it's -5. It's not between 0 and 10, but some of our answers could be negative numbers. In this case, x equals -5 could possibly be our other one. So we're just going to look at this, and it is -5 squared minus 2 times -5 minus 35 equals 0. It's 25 plus 10 minus 35. That's 35 minus 35, which equals 0. And there you have it. -5 and 7 is an x value that will make this equation zero, expression zero. Okay, well, how did we figure that out? Well, this lesson's actually going to start with this warm-up's actually preparing you for learning how to find those x values, and it has a lot to do with factoring, rewriting your expressions into factored form. So today that's what we're going to do is we're going to actually use the concept you may have learned earlier called the zero product rule. And the idea is that you're going to use that rule to help you understand how to actually rewrite expressions into factored form and then be able to find your answers like the 7 and the -5. So just so you guys know what zero product rule is, I'm going to just go over it really quick. So the concept of zero product property, not rule, sorry, property is that multiplying by a factor of zero will get you an answer of zero. So that's the idea with zero product property. Okay. So the idea again is just making sure that you understand that by multiplying by a factor of zero, it's going to be essential for us in this concept because multiplying by zero, anything by zero will always get us zero. So if we could get our expressions into factored form, then you're always going to have one factor that's going to be zero. It doesn't matter which parentheses zero. So what I mean by that is if we could get x minus a or times x minus b or something like that equal to zero, x minus a equals zero, we'll multiply this whole thing out to be zero, or x minus b could be zero. And then that if this is zero, then this zero times this would also equal zero. So that's the idea of zero product property, which you may have heard about in prior lessons. All right, so let's continue on. Okay. Let's solve some equations. 9.2. To solve the equation n squared minus 2n equals 99, Tyler wrote out the following steps. Analyze Tyler's work, write down what Tyler did in each step. So if we look at each step, here's his original equation. It looks like he moved the minus 99 over here. So in order to do that, he would have to subtract 99 on both sides. Okay, that would get him zero here, and that's why we have a minus 99 there. Now, why would he do that? Well, the goal is that we want the equation set equal to zero. Okay, so if we could get our equation set equal to zero, then we could factor and then use that zero product property to help us solve. So really, you're just setting your equation to zero. Set equation to zero by subtracting 99 on both sides. And that's the main goal, set equation to zero. Okay, so then you'll notice the next thing they did was they factored. So they found a number, two numbers that multiply into -99 and then add up to -2, which makes sense because -11 times 9 would get us -99 and -2, -11 plus 9 would get us -2. And we could just double check that. So -9 equals -99. And then we also have -11 plus 9 equals -2. Okay, so it just shows you what they did next is they rewrote in factor form. Okay, so we're rewriting this in factored form. Okay. Step two, we're going to use the zero product property. So right here, we're setting both factors to zero and solving. So use the zero product property. Okay, so setting both of them equal to zero, because we know if one of these factors is zero, the whole thing will just be zero. And then the last step is to solve for both x values. Oops. Okay, so solve for both x values. So it looks like they added 11 here, added 11 here, and then minus 9 here, minus 9 here. Okay, and then that's how we get our answers. N equals 11 and n equals -9. There you go. So here are the steps for solving quadratic equations by using factored form. All right, let's flip. We're going to do some more. So let's practice some more solving quadratic equations with factored form. So solve each equation by rewriting in factored form. So that's the main goal, is to rewrite it in factor form. Okay. And using the zero product property. Show your reasoning. Okay. Let's see if I could give myself some room here. Okay. So the first one, so let's look at this. You want to find two factors that multiply to 15, but add to 8. So that's our goal, is we want to find two numbers that are going to multiply to 15, but add to 8. My other green highlighter is kind of dead, so I'm going to try to see if this one works. Actually, let's see. It works better. Oh, it works better. Okay. So two numbers that multiply 15 but add to 8. Well, that would be 3 and 5. So x plus 3 and then x plus 5. And I'm going to set it equal to 0 still. So 3 times 5 is going to get me 15. 3 plus 5 will get me that 8. And now I can use the zero product property. So let's look at that. I'm going to set them both equal to 0. So because if one of them is 0, then the whole thing would be 0. Or x plus 5 equals 0. Okay. To solve for this, I would minus 3 from both sides. That would get me -3 if I minus 3 from both sides. And then this one would be -5 if I minus 5 from both sides. So there's my answers. X equals -3 or x equals -5. Okay, so let's do this again. We're gonna look again. But in this case, we gotta be careful because if you see right here, this is not set equal to 0. We want it set equal to 0. So we're gonna minus 5 from both sides here. Okay, so that's gonna get me 0. And then 12 minus 5 is gonna get me 7. So then I'm gonna bring everything else down. Okay. So I got x squared minus 8x plus 7 equals 0. Now I'm going to factor that. I'm going to draw a light line here to separate the two. So this will be b. So let's factor it. X multiply to 7, but add to -8. Okay, so two numbers that are going to add to 7, but multiply or add to, sorry, multiply to -7, but add to -8. That would be 1 and 7. So that'd be 1 and 7. And they would have to both be a negative because I need a -8. So there you go. Set them equal to 0 with the zero product property, or x minus 7 equals 0. Okay, solve. I'm going to add 1 to both sides. That's going to get me a +1 or a +7. And if you're not sure if your answers are correct, you can plug it back into the expression to see if it makes it true. So I could take the 1 and plug it into this original expression and see if it actually equals 5. So that's another way to check your work if you're not sure if your answer is correct or not. Okay. All right. Set equal to 0 ready for us. So that's x. We're going to do parentheses, factored form. That would be 1 and 11, and I need a -10. So that would be a -11 and a +1 to get that -10. So again, it multiplies to -11, but then it adds to that -10. Okay, set it equal to 0. Because again, if one of these factors is 0, anything times 0 is just going to be that 0 there. So -1 on both sides, I would get a -1 when I solve for that. Um, Add 11 to both sides, I would get a +11 for that. Okay, so those are my solutions. You'll also notice that a lot of these equations right now have two solutions. We'll talk about other types of solutions a little bit in a bit. You may have heard it already, but we're going to talk more about it. All right, D. Oh, look at that. This is a difference of squares. This is the difference of squares. We just learned that in lesson 9, I think. So last Friday. So that means I'm going to have two set of parentheses, 49. So what's one number that multiplies to 49? That would be 7. And then x. So these both would be x. And then remember with the difference of squares, one's a I can't talk, sorry. One's a plus and one's a minus because they'll cancel that middle term out. So -7x would, and then 7x would become that 0 you want in difference of squares. Okay, so now we're going to just solve it. So 7 plus x equals 0, or 7 minus x equals 0. Well, 7, if I add -7 on both sides, I'm getting -7 here, right? Because 7 plus -7 gets me 0, or x equals 7, because 7 minus 7 equals 0. Where's my highlighters? Okay, all right. And then last one. Notice that we have, this is not in factored form because we have a -30. So what you're going to have to do is you're going to have to multiply these out. So you're really going to actually have to multiply that expression in the middle out. Okay, so we're going to factor that out. So if I do that, not factored, distributed out. X squared, right? And then I have 4x. I'm going to have 4x, and then I'm going to have 5x. So that's going to get me 9x. And then 4 times 5 is that 20. Okay, so I just factored that out into that expression. And then you'll notice the next step you can do is you can combine terms here. So this part here, I can combine. So I get x squared plus 9x, and then 20 minus 30 is minus 10 equals 0. So now I can factor. So I need to multiply to negative 10, but I need to add up to 9. That would be 1 and 10. And because I need a positive 9, that's going to be a minus 1 and a plus 10. Okay, so x minus 1 equals 0, or x plus 10 equals 0. That's x equals 1, or x equals negative 10. And there you have it. Some practice with solving quadratic expressions. Okay, so let's move on to the next part. 9.3. Okay. So we're going to go over 9.3, revisiting quadratic equations with only one solution. The other day we saw that quadratic equations can have 0, 1, or 2 solutions. Sketch graphs that graphs that represent 3 quadratic functions. One that has no zeros, one with 1 0, and one with 2 zeros. Okay, so if I do that, sorry. All right. So if I do that, let's see if I could sketch here and do a little rough sketch. Okay, so that's my Y, that's my X. The idea of something that is a quadratic with no solution is the fact that you would not have anything crossing this x-axis. So you'll have a parabola that will look like this. Okay, and you'll notice that's my vertex there. Okay, but you'll notice nothing crosses that x-axis. So that would be a no solution because it does not cross that x-axis at all. Okay, so that's a no solution. Okay, a one solution would be that the line would have to cross the x-axis at least once. So it would make sense that it would possibly be the vertex that would cross. So right there. Okay, so the vertex is on that x-axis. So you'll see that right there. The vertex is crossing that x-axis. So this would be a one solution. And then a two solution graph means that our graph, our parabola, would cross the x-axis twice. So this would be a two solutions. Okay. And that's actually our x-intercepts there. Oops, my bad. Okay, right there. So that's our x-intercepts right there. Okay, so that's the two solution. We would actually have multiple or two x-intercepts. All right, using graph technology to graph the function defined by x squared minus 2x plus 1, what do we notice about the x-intercepts of the graph? Right. You may have some graphing calculators. If you don't, then you can use Desmos graphing. That's kind of what I'm going to use because I do not have a graphing calculator. So hopefully you guys can see my screen there. And I'm going to punch that in. So x squared minus 2, oops, my bad, 2x, and then it's plus 1. Okay. So what do I notice from this graph? Oops, my bad. Gonna zoom in if I can. Okay, so hopefully you guys can see it. A few things I noticed. I noticed there is 1 point at 1, 0. And then I also noticed that there's a y-intercept at 0, 1. So that's something I'm going to write down here is that there's an x-intercept at 1, 0 and a y-intercept at 0, 1. Okay. So right here, the x-intercept is the part that's the important part. So the x-intercept, the fact that I only have one x-intercept means I only have one solution for this function. Okay, and it's actually the solution to the equation because if I did plug this in, I could see that it actually would equal to 0. So I'm going to do that. X squared minus 2 times 1 plus 1, and we're going to see if it equals 0. So 1, that would be 1 minus 2 plus 1, that definitely equals 0. Okay, so right there, we know it is a solution to that expression. Okay. Solve x squared minus 2x plus 1 equals 0 by using factored form and the zero product property. Show your reasoning. What solutions do you get? So we're going to do x squared minus 2x plus 1 equals 0. Factored form. I'm going to factor it. So that's an x and an x. What multiplies to 1? That's 1 and 1, but I need a minus 2. So that means both of them are a minus. And these are the same expressions, so it wouldn't matter. I would just solve for x minus 1 equals 0. And that leads me to x equaling 1, which is perfect because that's what I got earlier, is that expression right there. Okay, and that's what I got here. Okay, which makes sense because that was my x and that was my y. Okay, all right. Write an equation to represent another quadratic function that you think will only have 1, 0. Graph it to check your prediction. Well, I noticed this pattern when it's the same expression. I only have to solve for one answer, so I'm going to do the same thing. I'm going to start with another expression. Let's do x plus 3 and x plus 3 equals 0. And then I'm just going to multiply it out in standard form. So x times x is x squared. 3 plus 3 is 6x. And then 3 times 3 is 9. Okay. And it should get me -3 as my answer if I did this correctly. So let's graph and see what I get. Oops. Oh no, plus 6x plus 9. And let's look at what I get. And you'll notice right there, see, I only crossed the graph once at -3, 0. So, yep, that equation will get me only one solution. Right. Well, thank you for listening to the lesson today. I hope this video was helpful for you guys in learning how to solve quadratic equations by rewriting equations in factored form. Have a great day.